something like x is, say, a sine omega t, or x is a cos omega t, or etc., anything in which x double dot is minus omega squared into x will be a simple harmonic oscillator, with omega being the angular frequency, time period being 2 pi by omega. Amplitude will not be determined from this. Amplitude is determined from this. Amplitude is not determined from omega. Omega and amplitude are independent entities, and they, amplitude, like I told you, would be supplied by us. Omega would be the systems. The system will determine the omega. Omega is root k by m. So if you know the force constant of the system is not under your jurisdiction. The mass of the particle executing SHM is not under your jurisdiction, right? Now, phi means nothing. I told you that day. It depends on, at t equal to 0 where the particle is. So it could be 0. If at t equal to 0, x was 0, phi is 0. Phi has nothing to do with all of this, right? Phi, I told you, is only mathematical. It has no physical importance, and it's called a phase constant, like I mentioned to you, right? So now, think of the following. Forget SHM for a few minutes. Okay? Think of a particle executing uniform circular motion. Think of a particle executing UCM, uniform circular motion, with angular velocity omega. Particle executing uniform circular motion with angular velocity omega, constant omega, right? With O as the center, and say this is a certain diameter of that circle, PQ. Let's say the radius of the circle, OP equals OQ equals A. Let's say A is the radius of the circle, and there is a particle at t equal to 0, and let me call this as the x-axis and this as the origin of coordinates. Let me refer to this direction as the x-axis and this as the origin of coordinates. Now, say this particle goes in this circle with constant omega. At t equal to 0, let's say this is where the particle was. Let's say t equal to 0, this is where the particle was, right? T seconds later, the particle, let me call that particle as P naught. T seconds later, that means at an instant of time t, it would arrive at some point here on the circumference, right? And it would have described an angle theta at the center equal to omega t. It would have described an angle theta at the center equal to omega t, right? Now, for every, and this length is a units, the radius of the circle is a units, right? A theta? What a theta? Theta equal to omega t. Why a theta? Angle described at the center is omega into t, isn't it? Omega is the rate at which angle is described at the center. In 1 second, omega radians is described. In t seconds, omega t radians is described. Yes or no? You people need to have more tests. Okay. Now, see, omega radians described per second at the center. So in t seconds, omega t if omega remains constant, right? Now, for every position of P naught on the circle, I can conceive of its projection Q naught on the diameter PQ. For every position P naught, I can conceive of a unique Q naught on the diameter of the circle. Yes or no? When P naught was here, Q naught was also here. When P naught arrived at this position, Q naught also arrived at this position. When P naught arrived right above O, Q naught was here. When P naught was here, Q naught was here. When P naught was here, Q naught was here. When P naught was here, Q naught was here. What was Q naught? Q naught is an imaginary particle. We are only imagining this particle, which is the projection of P naught on the diameter PQ. Yes or no? Q naught is the projection of P naught on the diameter PQ. For every position P naught, we can conceive of its projection Q naught on the diameter PQ of this circle. Yes or no? Right? So while P naught moves around this circle, with constant angular speed omega, Q naught shuttles along a straight line between P and Q, isn't it? Q naught would shuttle along a straight line bounded between P and Q. Its leftmost extremity would be P, its rightmost extremity would be Q. Clear? Now, theta is omega t. So when P naught has described angle theta at the center, the x coordinate of Q naught is this. This is the x coordinate of Q naught. It's going to be a cos theta. T seconds later, the x coordinate of Q naught is going to be a cos theta, right? So motion of Q naught is given by x at any given instant of time t. This is at t. This will also be at t. This will be x at t. Is going to be a cos theta yes or no, which is like a cos omega t is the motion of Q naught. The motion of Q naught is described by x as a cos omega t. Motion of Q naught therefore must be simple harmonic. Yes or no? Right? Or Q naught executes SHM between P and Q. Right? Where P and Q would be the amplitude positions of Q naught. P and Q being the amplitude positions of Q naught. Yes or no? Right? O being the mean position of Q naught. Q naught executes simple harmonic motion with amplitude A, angular frequency omega, and limits P and Q and mean position halfway between P and Q, that is the center of the circle. Right? So the understanding is simple. If I conceive of a particle executing uniform circular motion with angular velocity omega naught, then its projection on a diameter PQ will execute simple harmonic motion with amplitude equal to the radius of the circle, with angular frequency equal to the angular velocity of this particle. Yes or no? Omega is the angular velocity of this particle, and that becomes synonymous with the angular frequency of its projection. Right? If omega is the angular velocity of P naught, then omega becomes the angular frequency of oscillation of Q naught. Yes or no? Right? Now, which is a very simple thing, but a very versatile one at that. So while the motion of P naught is very simple, how simple is it? Constant angular velocity is very simple motion. The motion of Q naught is complicated, simple harmonic motion with angular frequency matching with the angular velocity of P naught, right? Now, by the time P naught completes a full circle, see, if P naught starts from here, it completes a full revolution, right? What's the time taken by P naught to complete a full revolution? It describes 2 pi radians at the center at the rate of omega radians per second. That's the time taken by P naught to complete a full revolution. P naught to complete a full revolution. And what happens to Q naught? See, P naught starts from here, it goes this way, goes this way, this way, this way, and back to this. That's a full revolution for P naught. In the meantime, what does its projection Q naught do? It starts from here, it goes here. So when P naught is here, Q naught is here. Now P naught goes this way, so Q naught goes this way. P naught goes this way, Q naught goes this way, and now by the time P naught comes here, Q naught again arrives at this position. So then, by the time P naught has executed a full circle, Q naught has executed a full cycle. Yes or no? By the time P naught executes a full circle, Q naught executes a full cycle. Yes or no? And the time taken for a full circle of P naught must be the time taken for a full cycle of Q naught. Therefore, the time period of motion of this simple harmonic oscillator is 2 pi by omega. Yes or no? Last time we found the time period in a lot more complicated manner. Xt is xt plus 2 pi by omega. Vt is v at t plus 2 pi by omega. But now we don't have to do all that. Realize that. So now, in this case, the way we looked at the whole thing is we started with a particle executing uniform circular motion and looked at its projection, which we found was executing simple harmonic motion. And the oscillator, this was the oscillator, had its angular frequency synonymous with the angular velocity of P naught. The motion of P naught was simple, and the motion of Q naught was complicated. But the motion of P naught could be mapped to Q naught, could be made complicated. Let's just do the reverse, in the sense that instead of starting with a particle with uniform circular motion with angular velocity omega, let's start with an oscillator. Then this becomes the corresponding particle on the circle, while this executes simple harmonic motion with angular velocity, with angular frequency omega. This simpler projection on the circle will execute uniform circular motion with constant angular velocity omega. Therefore, we would, instead of mapping from P naught to Q naught, why not map from Q naught to P naught, which is simpler motion? Yes or no? That's a philosophy, right? So, what we do is, think of a particle executing SHM between limits, say P and Q, with mean position being A, O, and amplitude of the oscillator being A, and omega being the angular frequency of this oscillator. Right? Mean position O, extreme positions P and Q. There is an oscillator Q naught executing simple harmonic motion with amplitude A and angular frequency omega. So then, if there is this oscillator we are talking of, then this oscillator could be mapped to a particle on this circle. The motion of q naught could be mapped to the motion of p naught, uniquely mapped to a motion of q naught, p naught, right, whose motion is very simple. While the motion of q naught has an angular frequency omega, the angular velocity of p naught is constant and is angular velocity omega, right? So this is the oscillator. This is the limits in which it will execute SHM. O is the mean position. With O as the center and amplitude as the radius, if we draw a circle, then we will refer to that circle as the auxiliary circle. We will refer to that circle as an auxiliary circle. And P naught now is a figment of our imagination, created by us for our convenience, right? P naught will be an auxiliary particle. P naught will be an auxiliary particle, right? So if q naught is here at some instant of time and is moving leftwards, P naught would be here and would be moving this way. When q naught comes here and is moving this way, then P naught would be here and would be moving this way. When q naught is somewhere here and is moving this way, then P naught would be here and would be moving this way, and so on and so forth, right? I hope you realize that the motion of PQ naught is completely mapped, uniquely mapped to the motion of P naught, right? Yes or no? Therefore, and the motion of P naught is simple. The motion of Q naught is complicated, whereas the motion of P naught, the auxiliary particle, is very simple. Uniform circular motion with constant angular velocity omega on this circle, right? Which means say this is the auxiliary circle for a particle executing UCM between P and Q, not UCM, simple harmonic motion between P and Q of amplitude A, angular frequency omega for a particle, right? Now, suppose at some instant of time the oscillator is here and is moving in this direction. The auxiliary particle will be here and moving this way on the circle, right? And with an angular velocity omega, which is the same as the angular frequency of the oscillator. After a while, Q naught comes to this position and P naught and is moving, say, leftwards, and P naught is here and is moving this way, right? Now, if I have to find the time taken by Q naught to go from, let's say, this position to this position, if I have to find the time taken by Q naught to go from this position to this position, instead of dealing with Q naught, why not deal with P naught? That's the same as the time taken by P naught to go from, let's say, this position 1 to this position 2 at constant angular velocity omega. Yes or no? And realize that when P naught describes this arc, it subtends this angle theta at the center. So by the time P naught describes an angle theta at the center, Q naught goes from position 1 to position 2. Yes or no? So don't deal with Q naught, deal with P naught. And the time taken by P naught to go from this position to this position is the angle that it describes divided by the rate at which it describes that angle, radians per second, that many seconds, right? So from geometry, if I can find theta, then I would rather deal with P naught, the auxiliary particle on the auxiliary circle, rather than the oscillator. Because the motion of the oscillator is complicated, the motion of its auxiliary particle is simple, right? Now, see, no, there is no rule like that. We could have just taken the reverse, but maintain consistency. For a given situation, if you have taken that, I mean, if I have taken Q naught going this way and P naught going this way, then for that situation maintain that. Or if I have taken Q naught this way and P naught going this way, then maintain that throughout. Just be consistent with that. It does not matter, right? Now suppose, no, how can it be the same? How can this arc length be equal to this? Certainly not. Independently, right? Now you might be a little tired, but deal with me for some more time, please. Say this is an oscillator executing SHM between P and Q with angular frequency omega. And I want to find the time taken by the oscillator to go from P to halfway to the mean position, from the extreme position to the mean position. Extreme to mean. Yes or no? I want to find the time taken by the oscillator to go from P to O, from the extreme amplitude position to the mean position. So while the oscillator goes from P to O, the auxiliary particle covers this. That means the auxiliary particle covers 90 degrees at the center at the rate of omega radians per second, right? Therefore, the time taken by the auxiliary particle to describe 90 degrees at the center is pi by 2 divided by omega. But omega is 2 pi by the time period of motion, right? So this is pi by 2 into 2 pi by t, which is t by 4. T by 4. Omega is 2 pi by t. Omega is 2 pi by t. So this becomes t by 4. So from an extreme position to the mean position, the time taken is 1/4 the time period of oscillation, right? Suppose I want to find the time taken to go from the halfway the amplitude position, that means at x equal to a by 2. The oscillator is at x equal to a by 2, halfway between the mean position and the extreme position, and is moving in this direction. I want to find the time taken to go from x equal to a by 2 to the mean position, right? So while the oscillator is here, where is its auxiliary particle? The auxiliary particle is here. Yeah, that's okay. It will not make any difference. Then both I'll take downwards, right? While the oscillator comes here, its auxiliary particle comes here, right? Now, the angle that the auxiliary particle describes, so instead of dealing with the oscillator going from a by 2 to 0, I would rather deal with the auxiliary particle going along this P naught, right? And it will describe an angle theta at the center, right? Realize that this is a by 2, this is a, this is a, this is a by 2. This angle is theta. So cos theta is a by 2 by a. Cos theta is half. Theta is 60 degrees. Theta is 60 degrees, isn't it? I hope all of you understand this. Huh? Theta is 60 degrees. Therefore, the time taken by this at the rate of omega radians per second is going to be theta divided by omega, right? Theta, which is pi by 3 divided by omega. Omega is 2 pi by the time period. 2 pi divided by t, that makes it 1/6 the time period. 1/6 the time period to go from halfway between the extreme and the mean position to the mean position. 1/6 the time period, and so on and so forth, right? So this business of auxiliary particles, reducing the problem to an equivalent auxiliary particle on the auxiliary circle, is a powerful tool, a versatile tool. We can migrate from the oscillator to its auxiliary particle, deal with the auxiliary particle, and translate those results to the oscillator, right? That is what we do. This much for today. Have fun. Bye-bye.